Okay, we're going to look at some questions on functions now. Oops. Functions. So let's just start off with some real basic things about functions. So we're talking about things that look like this. F of x equals perhaps something like 2x minus 7. Now, what does this mean? Well, it means that f is some function that takes in, so f is a function, and then this bit means that takes x as an input, and then the equals could be thought of as and produces. Okay, now what does this mean? 2x, well, that's 2 times the input. So and produces 2 times the input. That's this bit. This is 2 times the input. 2 times x. X was the input, so this is 2 times the input. Subtract 7. So we have f is the function, takes in an input of x, and produces 2 times its input, and subtracts 7. Now, we can think of that as basically starting with an x as an input. This is my input. And we then multiply by 2 to get 2x. And then we subtract 7 to get 2x minus 7. And that gives us our output. Okay, and quite often our output is called y. Sometimes it might be called f of x. Okay, so that's what we've got here, f of x. Okay, and this is of course our output. Now when we solved equations, for example, if we'd have solved 2x minus 7 equals 4, the way I asked you to do that was to look at the x and build up and construct the left hand side. I said, well, from the x we first multiply by 2 and then afterwards we subtract 7. Okay, and then I asked you to solve that by going reverse through and doing the opposite. So first of all we would add 7 to both sides, and then we do the opposite of times by 2, which would be divide by 2. And that gives us a way of working out what the inverse of a function is. Let's just remove that now. So the inverse So if f of x is 2x minus 7, then the inverse is basically going through this diagram backwards. So what do we do first? Instead of subtract 7, we do the inverse of subtract 7, or the opposite of that, which is add 7. So our inverse, remember we denote our inverse of our function, f to the minus 1. So we're starting off with the input, and we're adding 7 to it. So we start off with our input, then we add 7, and after we've done that, we go to our next stage, and we do the opposite of multiply by 2, which of course is divide by 2. And we must divide everything by 2, so we do that. Now, you may recall that that's the same process as saying let y equals 2x minus 7, and then we rearrange to get x equals. So what do we do to do that? Again, we multiply by 2 from the x to get 2x, and then we subtract 7 and we do the reverse. So we're going to add 7 to both sides, so we get y plus 7 equals 2x. And now we do the reverse of times by 2 on both sides, so we divide both sides by 2, and therefore we get y plus 7 over 2 equals x. Now you may also recall that there is a relationship between a function and its inverse. in that it's the reflection in the line y equals x. We looked at several examples there. So if a function might perhaps look like this, then its reflection would look like that, a reflection in the line y equals x. So we can swap over the x's and y's. So here we get y equals, instead of x equals, we've got y equals. Let's leave the order the same. So instead of this y, we're going to write x, and instead of this x, we're going to write y. And that tells us, therefore, that my inverse function is x plus 7 over 2, which is the same result as doing it this way. Multiply by 2, subtract 7, go in the reverse order. We start with an input of x, we add 7, and then divide by 2. Same idea. Whether you prefer to do it this way, with these sort of splitting the operations up like this, or whether you prefer to do it using the order of the operations this way, in the same way that we solved equations, it's up to you. So that's a function and its inverse. Let's now do another example with functions. So let's do another example. If the function f is defined so that f takes in an input x and produces 3x minus 7, and we've got a different function, let's call it g, and its job is to take an input x and produces, let's say, x over 4. Okay. Certain types of questions might ask you to find, let's say, A, we're trying to find maybe f of 3. And B, we're going to try and find g of 12. And C, we start to do the composite function, so f g of x. We'll come back to that in a minute. Okay, let's start off with part A to that. Okay, f of 3. Now, remember, we read this as f is the function here that takes in x as a value for an input and produces 3 times its input, 3x, 3 times its input, and then subtract 7. This time, what am I feeding into f? I'm feeding in a 3 into my function. So the function f multiplies its input by 3, so f of 3 is equal to 3 times my input, subtract 7. In other words, I'm replacing all of the x's with 3's. And what do I get there? I get 9 minus 7. 3 3s are 9. 9 minus 7 is 2. Okay, part B, g of 12. This is saying that I take my function g, and the job of g at the moment is it takes in an input of x and produces its input divided by 4. So we want its input, which is 12, and we divide it by 4. 12 over 4 is 3. So g of 12 is 3. Part C is a little bit harder. f g of x. Now you may recall that I said I prefer this notation. I want you to remember that fg is not multiplication. Okay? You remember in class when I got people to stand up, and I had one boy who was the machine called f, and his job was to multiply the input by 3 and then subtract 7. And then we had a composition where we had got 2 of you to stand next to each other, and you whispered in one ear a value of x, and then that get passed on to the next function, making it a composite function. That's how we do that. So the way to do that is what we're going to do is we're going to start from the inside and work outwards. So we're going to leave this outer function, f, just as it is, and I'm going to replace this g of x with what g of x is. And what is g of x? Well, it's written right here for us. It's x over 4. Okay, we're going to get a mark for doing that. Okay, typically we would anyway. Simply replace this inner function, g of x, with what g of x actually is up here. Now, what does our function f do again? Well, it triples our input and then subtracts 7. Now, our input this time is x over 4, so we're going to triple that, triple our input, and subtract 7. And we could write 3x over 4 minus 7 if we wish. Remember that 3x over 4 minus 7 is the same as 3x over 4 minus 7, or which is the same as 3x over 4 minus 7. Okay, that's how to do those. So start from the inside, work outwards.